Section 1.4, Solving Absolute Value Equations. Before we get into the new material, let's do a quick review of what absolute value does. We have three pretty easy examples right here, just evaluating absolute values. We know that the absolute value of 3 remains as 3 because the absolute value takes a positive number and keeps it the same. The absolute value of 0, which is neither positive nor negative, stays again the same, stays as 0. And the absolute value of negative 3 is the only time absolute value really does anything. The absolute value of negative 3 is positive 3. Absolute value, as we mentioned down here, can never be negative. So we have to turn it from a negative 3 into a positive 3. Okay, so that's what happens if our unknown value is outside of the absolute value, but what if our unknown is inside the absolute value, like these three examples here? Well, at first glance, it may look pretty straightforward, but the first problem is actually more complicated than it looks. The absolute value of x equals 4, what we want is we want to figure out any value for x that would make that true. Well, the obvious one is x equals 4, but it turns out that there's another option as well. The other thing that we could plug in would be x equals negative 4. And it may be the type of thing that you just didn't think about, but now it makes a lot of sense. If you're going to take the absolute value of a number, it can be either positive or negative 4 if your answer is 4. Now the second problem says the absolute value of x equals 0. Well, there's only one thing you can plug in and get an absolute value of 0, and that has to be 0. So in this case, we only have one answer, although we had 2 in the front. And then we look at the last one. It says the absolute value of x equals negative 4. Well, I can't plug in a negative 4 for x because that'll turn it into a positive. Turns out there's nothing we can do there. This problem actually has no solution. Again, because of what I referenced down here. The absolute value of a number can never be negative, so that's never going to happen. Alright, let's start to solve some equations. So, solving an absolute value equation, or any equation that involves an absolute value of a variable expression, is not too difficult, but there are a couple of things that we need to do. First, we need to isolate the absolute value on the left side of the equation. That means taking this whole thing and getting it by itself, almost as if it was just one big x. So in order to do that, I'm just going to add 5 to each side, just like I'm solving a regular equation, which is going to give me 2 absolute value 2x plus 1 equals 12. And then the 2 right outside the absolute value means multiplying, so I'm going to divide each side by 2. And that leaves me with the absolute value of 2x plus 1 equals 6. Alright, so that's the first step. I have to get this absolute value completely by itself. It's still the absolute value of 2x plus 1 on the left side of my equation. Now, that's a difficult equation to solve. So what I have to do is I actually have to split it up into 2 equations. This is what that looks like. My first equation, my second equation are going to look very similar. The first one is 2x plus 1 equals 6. It's exactly the same equation, but it's without the absolute value bars. The second equation is 2x plus 1 equals, now instead of 6, I'm going to make it a negative 6. And that comes from multiplying the right side of the equation by negative 1. 6 times negative 1 becomes negative 6. And those are my two values right there. So I have my two equations, excuse me. 2x plus 1 equals 6. 2x plus 1 equals negative 6. Now we have two easy equations to solve. Go ahead and solve those, and I'm going to do that quickly here. Alright, so we see that we end up getting x equals 5 halves, or x equals negative 7 halves. Those are the two different solutions. Doesn't mean we get to choose which one we want. It means that both of them are solutions. Now, very important with absolute value, we actually want to check our work by plugging our solutions into our original equation. So let's move this over here so we can do that. And we're just going to plug in one at a time. So I'll start with the 5/2. And so you see I've plugged this in here. I'm just going to go ahead and simplify the left side of this equation, and hopefully I get something that equals 7. Alright, so you can see that when you just do the order of operations, you end up getting 7 equals 7, which works. Let's do the check with the negative 7/2 as well. And you can see here that once again we get 7 equals 7. So negative 7/2 is also a solution. Notice that the difference between the two checks is that at this point up top we have the absolute value of 6, whereas down below we have the absolute value of negative 6. That comes from these two different equations, but in both steps the absolute value of that goes to positive 6, which we started with there. So that's pretty much how you do it. You have to isolate the absolute value on the left, split it up, drop the absolute value bars, and make the right equation a little different by multiplying the right side by -1. Solve it, and then go ahead and check your work. Alright, let's get some more practice in. Alright, here are two problems. The one on the left is a little bit simpler. I want you to go ahead and try to solve that one, then come back and check your work. Alright, let's see how you did. Alright, so this one was nice because the absolute value is already isolated on the left, so it's just a quick split and then make the right side of the right equation -11. And then we solve and we get x equals 5 or x equals -17. Didn't show the check, but you should do it just to make sure. Even mentally, plug in the 5, get the absolute value of 11, which is 11. Plug in the -17, you get the absolute value of -11, also 11, so both work. That's going to come in handy later. Alright, now give the second one a shot and come back and see how you did. Alright, let's check your work. And so here you can see that we get x equals 4 or x equals 0. Once again, for the check, just plug in. If you choose 4, 3 times 4 is 12, 12 minus 6 is 6, and the absolute value of 6 is 6, which 6 minus 9 is -3. And if we just use 0, then 3 times 0 is 0, so the absolute value is asking for the absolute value of -6, which is 6, and that minus 9 is -3. Alright, so there you go. Hope this is starting to make a little bit more sense. Here's a quick warning for you. Don't do too much work. I know that's something that you'd be happy to hear. If you look at the left equation here, the absolute value of 3x plus 5 equals -8. We're going to be tempted to split that up and make two new equations. But we remember that the absolute value can never be negative. So right away we can draw the conclusion that this has no solution. If you went ahead and tried to solve it, you would end up getting two answers, but when you plugged in to check, you would end up getting the absolute value of 8 or the absolute value of -8 equals -8, which is impossible. So when you go back to check, that's when it wouldn't work. But you don't even need to, because the absolute value equals a negative number. You can say right away that there's no solution. Similarly, let's look at the other one, where the absolute value of 6x plus 18 equals 0. Well, we normally would split this up, but if we split this one up, if we multiply the 0 by -1, we would just end up with 0. So we'd have two equations that are identical. So if you have the absolute value of something that just equals 0, just rewrite the equation without the absolute value bars, because the only way that that's true is if the inside of the absolute value is 0. And then go ahead and solve this by subtracting 18 from each side, leaving you with 6x equals -18, and then dividing by 6 to end up getting x equals -3. You can go ahead and check that in your original. 6 times -3 is -18, plus 18 is 0, and the absolute value of 0 is 0. So in this case, we didn't need to do the same equation twice. That would just be excessive work that we don't need to do. Alright, hope that helps you. Alright, so there's not too much that we'll do with word problems with absolute value equations, but there is something I want you to see so that you know how to set one up, because it's a question that you're likely to see on PSAT or SAT, something like that. When Mr. Callan drives to school, the longest that it takes him is 60 minutes, and the fastest that he has ever gotten to ARHS is in 30 minutes. Write an absolute value equation that represents the maximum and minimum lengths of his drive. So for a problem like this, it often helps to go back and think about when we first learned about absolute value, what it meant. And the absolute value of a number we said was the distance from 0, which means that it might be helpful to use a number line. And so on this, let's look at the two values we know. We know that the shortest amount of time is 30 minutes, and the largest amount of time is 60 minutes. So for absolute value equations, what we generally want to do, if we're trying to write them, is we actually want to find the middle of those 2 points, and not think about how far they are from 0, but how far they are from each other. And so either using the number line or using some subtraction or some averaging, we can figure out that the halfway point between these two things is right at 45. 45 is actually, you can kind of count here, 15 units away from 60 and also 15 units away from 30. And so that's actually the information that we're going to use to write our equation. We're going to have the absolute value of x, and it's going to say minus 45 because that's our middle point there. Our distance from 45 is how long? 15. That right there is the equation that you need to write for this problem. You could go ahead and solve this, and the two solutions you'd get would be 60 and 30, the maximum and minimum lengths of the drive. So for something like this, find the middle of the two values, find how far the middle is from each side, and then you'll have your equation once you fill in. Alright, so here are two advanced absolute value equations. The one on the left is advanced because the right side of the equation is not just a number, but actually a variable. And the right side, the right equation is advanced because there are two absolute values. I'm just going to take a look at these. We're not going to do too much of them, but I want you to be exposed to them. On the left, you're still going to do it the exact same way as you did with another problem, where you split it up into two different equations. And when you do that, you're going to get the first equation to drop the absolute value bars and just basically be the original. And the second equation, you want to multiply the right side by -1. So here you're looking at negative 6n. Alright, so go ahead at this point and solve this equation. Let's see how you did. Alright, so when we solve these, we get 6 equals n or -2 equals n. Go ahead and plug in, see what happens when you do a check though. What you may notice here is that the 6 equals n works because you end up getting the absolute value of 36 equals 36. That's not a problem. But when you plug in the -2, you're actually going to end up getting the absolute value of 12 equals -12, which is not true. The absolute value of 12 does not equal -12. So that is no longer a solution. So it's advanced because when we go back, we see that this actually doesn't work, and the only solution we have is 6 equals n. Alright, let's clear up some space so that we can, or just move to the side a little bit so that we can look at the next problem. Now for this problem, we're still going to split it up, and our two equations are going to look similar, but we're going to kind of ignore the fact that we have two different sets of absolute values, and we just have 2r minus 4 equals 2r plus 10. Let me give myself more room actually. Clear everything away. And then the other equation is going to be 2r minus 4 equals, and I'm going to multiply the entire right side by a negative. That means I'm going to have to distribute. Alright, go ahead and solve these equations and we'll come back. Alright, so we see in the first equation, we end up getting the statement -4 equals 10, which from our last section is one of our special cases that's false. And so there's no solution to this particular equation. That does not mean there's no solution to our original, because we still have the other arrow. When we go through and solve that, we get r equals -3/2, or -1.5. Plugging in to do our check, we should see that it ends up working out. Let's double check. So our check confirms that we end up with the absolute value of -7 equals the absolute value of 7, which both of them are 7. So this equation actually has one solution, just like the previous one. Now the previous problem, let's go back and just see that there. We had to throw out the answer of -2. That's something we call an extraneous solution. So anytime that you get an apparent solution and then go back and check and it doesn't work in the original, we call that an extraneous solution. Doesn't mean we did anything wrong, it just means it doesn't work with our final answer. Alright, I know this is a lot, but hopefully this covers all the material you need to solve absolute value equations. Nice job.